Welcome. Today we're going to be talking about basic architecture for building iOS apps. I've seen many talks and videos, blogs and books about this recently. I wanted to contribute a little bit myself. I also want to avoid the esoteric, complex, quasi-academic approach that these videos and tutorials quite often take. Hopefully just cutting to the chase and helping people from beginner to intermediate level to help launch you into your own app with a better structure. I'm going to start by showing you how I evolved from the standard MVC pattern and various layers that we've added to achieve a more cohesive and useful structure. And then we're going to finish by demonstrating how to structure code in a project file according to this new architecture that we've defined. Okay, time to dive in. Model view controller. You should be familiar with this already because this is the standard iOS SDK pattern. Going to summarize it anyway. So model, this is your domain specific components. This is where you'll keep your objects and your entities and where you'll describe the relationships between these objects and entities and also how the data flows in between them. View, this is all things user interface. So this is where you will define buttons, the colors, sliders, animations and such like. And controller, now this is where our first problem lies. Theoretically, everything else happens in the controller. And as you can imagine, this leads to massive view controller. You see, the problem is, as the MVC pattern does not explicitly define how to structure the view controllers, they usually get used as dumping grounds for everything else which don't fall into the view or the model category. And the class files themselves just get very big very quickly. This is similar to how app delegates can sometimes be found with everything in them, where somebody can't find a correct place for a particular component or a bit of code. Therefore, they slap them in the app delegate, or in this case, in the view controllers. This is obviously very bad. There are a few effective ways of tackling this. For example, you can embed controllers within your controllers. You can use delegation, you can use view models, and you can also use Blackmagic. The main problem here is that the view controller itself is taking on too much responsibility. We're going to explore view models now to try and alleviate this responsibility, try and take some of the responsibility away from that view controller. And we're going to use view models we're going to adapt the MVVM pattern. Model, view, view, model. Only joking about the Blackmagic. I guess if you can do it and it works, that's a bonus. Otherwise, I wouldn't waste my time on Blackmagic. So the idea is to place any data objects and behavior being used by the view into a separate layer. This abstracts out any of the domain logic away from the UI. The aim is to make the view layer as focused as possible only on UI stuff. In MVC, some of that domain logic can sometimes creep into the view layer. So our first adaptation of this pattern is clearly defining where our view controllers live. MVVM doesn't include view controllers. It's sort of a very generic pattern which can be used in various different technologies and software. So adapting it to specifically iOS development, we need to clearly define where our view controllers go, and we're going to put them underneath the view app and above the view model. So now the view controller's responsibilities are merely as a binding between the view model and the view. I call these two components the presentation layer, but you could call it the UI layer, the cosmetic layer, the graphics layer, front end layer, something like that. So the next adaptation is going to involve network code. Now, since we have a view model, which essentially contains a high-level layer of domain logic, our model layer requires a bit of redefining. And we can start this redefinition by combining network code with the model layer into what I will call a services layer. I always consider a networking layer as a facility for establishing a model from a remote source. Hence, to complete our adaptation of the model layer into a services layer, we should include local storage. And now we've got networking and local storage, we can sort of forget the single concept, the single idea of a single model layer, and just do everything either with local storage or through networking to establish our model, which is then utilized by the view model layer. So now we're confident with our horizontal layers. There's one more concept to talk about before we move on to the code and the project structure, and that is modularization. So using what was our model layer, but is now our networking and local storage, or our persistence layer, we can use the remaining three layers, the view controller, and the view model layers. We can achieve cohesion and being lightly coupled between each feature by separating these layers into vertical slices as well as layers, all sitting on top of the persistence layer. So this diagram does a much better job of explaining this than what I can do verbally. As you can see, we've got three features here, A, B, and C. They've all got their individual view controller, and view model layers, but are all they're all sitting on top of our persistence layer. Again, persistence layer comprising of networking and local storage. And if you think about this makes a lot of sense, because you don't want to be using lots of different networking objects, and you don't want to be accessing local storage in many different ways. You only want to be accessing local storage at one point. The features, however, the views and the view controllers, etc., they'll all be separately defined in their own way, and it means that it makes moving and adjusting and configuring each feature independently a lot easier. Anyway, let's move on to the code. Some of you may be familiar with the NEO Early Warning System app that's now available on the App Store. See the links in the description below this video for further information. All it does is hit the NASA public API, fetches a list of near-Earth objects, comets, meteors, and such like. So if we tap on this, we'll see a list. We've got a name and a date of the close approach date. And so what we're going to do for this demonstration is we want to recreate this list. Obviously, it won't look like this because we're not going to bother with any of the UI or anything. We're just going to create one single list which displays the name of each NEO. So let's crack on. So I'm going to be using version 9.3 of Xcode, which was updated itself this morning, and we're going to create a new project, full project. It just has to be a single view app, and we're going to just call it App Architecture Demo Project. Don't need any of this. Let's just crack straight on and put it in this folder. Nothing to be too concerned about there. So the first thing we need to do before we move on, to avoid confusion later, is just to quickly add the app transport security setting, just so we don't have any problems with not allowing HTTP and HTTPS requests out of the app. Then what we're going to do here is we're going to sort of reshuffle the way this folder structure looks inside our project file. Going to start by creating a new group and just call it project settings. and we're going to put the info.plist in there. And in doing this, just a little gotcha for you, it means that we have to update the location in the build settings. So if you go to your target, build settings, do a quick search for info, and then you should see your plist mentioned here, and we just change that to project settings. So next, I'm just going to delete that default view controller because we'll deal with that later. So if we're going to follow our architecture structure that we've already talked about, I'm going to start by creating a new view group where we're going to put these three. Now I know this doesn't exactly fit in with having separate features, but we're only going to look at one feature today, which is the list, and hence there's no need to create separate view groups for each individual feature because we've only got one. And then finally, I'm just going to pop this up here just because it gives you a better idea of the overall structure of the project. Whilst we're in here, let's just get rid of some of this boilerplate, as it is pretty much just going to get in the way for now. A lot less green. Boom. Now it should run. So we just do a quick run to make sure nothing's broken too much. Cracking. So we're going to march forward. Remember, we're going to try and follow clean code principles. And as I mentioned before, there's already a repo with quite a lot of the code that I'm going to use up on Bitbucket. So the first thing we're going to look at is the networking code. So I'm going to have two groups, one for networking and one for errors, because they both go hand in hand. And I'm going to reshuffle them down here. Come on. Like so. And we're not going to look at local storage just yet, so we're not going to bother doing a group for that. However, we're going to go and grab the network code from the repository. Okay, so it's simply just a case of dragging this into here. This is pre-written network code by myself. You're free to use it if you wish. And we also require the errors. Again, all written by myself, a little library that I've been working on, just to make these kinds of apps a little bit quicker to get up and running. Prototypes, fast prototyping, remember, all in the agile philosophy. Agile and lean startup, come on. There we go. One more adjustment that I need to make here, and that is the API key, the NASA API key. You'll have to go and get your own. I've put mine in a separate file. I'm just going to pop it here in the networking code group. And then in our URL string, we'll see that we've got API key here, and I've put blah, blah, blah. So here we just put secret key, and that should fix everything. So to ensure that all this code is working, I'm just going to pop a quick network session call in here in the app delegate. As I mentioned before, app delegate gets used as a dumping ground for quite a lot of stuff. So you want to try and avoid doing this, but we're just going to put it in here for now, just for testing purposes. So this calls a network session using the fetch items API, and it should give us an empty response body. Let's give that a run and see what happens. Nothing in the simulator has happened, but if we have a look down here, we'll see what has been printed out. So a success has been printed, and it's given us an empty response body. That is fantastic. Okay, let's move on. So we're going to add our first feature. Well, it will be our only feature. We'll add a new group, and we're just going to call it list. Keep it nice and generic, just to suit your suit whatever app you're working on. We're going to move those two up there so it maintains our architecture structure. Let's close these down so satisfy the OCD pangs. What we're going to do is we're going to create our first view controller, so we can extend from our Cocoa Touch class. I'm just going to call it list view controller, easy peasy. Blah blah blah, just create it, come on, stop messing me around. Again, just delete all this boilerplate stuff because we're not going to use it just yet. So what's going to be in this view controller? Well, simply just a connection to a UI table view. Implicitly unwrap it, a identifier, so we'll just call that list. Another thing that we're going to need is the data source for that table view. I like to put these in extensions in separate files just for readability and easily to be easily maintainable. So we'll just call it list view controller plus UI table view to emphasize that it is an extension. Easy peasy. So we're just going to copy that, pop it in here, but fiddle with it a bit and say UI table view data source, get rid of that. And when we try and build it, Xcode will probably give us some clues as to what we need to do. Add those stubs, boom, nice and easy. So we're just going to say there's no data in it for now. And here we can just return a UI table view, so easy peasy. Neaten that up a bit. Let's quickly add this to our storyboard so we can see it in action. So first thing we need to do is assign this to a class, and we're going to call it list view controller, boom. And then we're going to add a table view, like so. Just for sake of ease, we're just going to pop all that out and then quickly connect the constraints, boom. There's quicker ways of doing this, but I've just got into the habit of doing it this way. Now, need to ensure that the view controller knows what its table view is. We do that by connecting it that way. And then we also need to sort of loop back and tell the list, this table view, what its data source is. And we do that by connecting it that way. And if we run, everything should be hunky-dory and we should see an empty list view in our simulator. Yes, job's a good one. And we've also still got our empty response body there. The next thing to do is to get the view controller to fetch its own data. So first of all, we need a way of parsing the response in a format that we would like to be able to use. And we do that using Swift for JSON response decoding. So I've got this pre-written one here, and I'm just going to pop it in my list view group. Just have a quick look at that. So all that does is parses the JSON. I've analyzed the response from the API already, and this is how I've determined the response body to look like. Now, we can delete that network session from the app delegate, where it does not belong anyway. And we're going to put that network code into our view controller in the will appear lifecycle function. Something else that we need is to define the view model. So in here, I'm going to create a variable which is list items, and for now we're just going to create an array of strings which will represent the name of each near Earth object being displayed on our list. I'm going to pop the network code in here. I've enhanced it a little bit. So now we receive the fetched item response body, which is passed in our network session. And we also pass each individual item using a flat map, and basically just get the name string from each NEO and add it to our list items. Once all that is done, back on our main thread, we reload the list. However, we have not yet told the list how to populate itself. So first of all, we go in here and we tell it has a number of items equal to the number of items in our list items. That's our number of rows. Secondly, we need to create this cell and then return the cell. Obviously, you will use DQ cell, but for the sake of speed, I'm just going to go boom, text label dot text equals list items index path dot row. Boom. Run that, see what the errors are. Yeah, so we need to unwrap some things here, so we'll do that. And there you have it, our list of NEOs. Now that might have been a bit too quick for you to see, but the idea is that we have the feature, we have the top layer, which is the view. I've included assets and storyboards in that. And then we have a separate layer for networking, and the error layer could be considered part of networking. And there you have it, easy peasy. In our case, the view model is represented by this list items, this array of strings in this list items variable. So that concludes this session. Hopefully I've conveyed the idea of clean architecture, and hopefully the demonstration wasn't too difficult to follow. Feel free to contact me on Twitter, my handle there, bottom right corner. Check out the Bitbucket repo. Feel free to use the code or just adapt it to whatever you feel necessary. I can also highly recommend the guys over at objective-c.io, that's objc.io. They're working on a book at the moment which describes this material but in a much more advanced way. And also feel free to get in touch. Bye.